Okay, so this is where we left off. We have our basic, cake animation in place. Okay. Now, the great thing is that even if you just bring up the noise right now, it will start looking interesting, because you just have that detail coming in. So what we can do with the noise, just to sort of show you, is we can just animate the amplitude values, right? It's basically that simple. So what we do is we just come to the parameters that we want to animate. So we want to animate the amplitude here. Okay, so we can just take this to promote parameter and maybe also promote this guy. Okay, so we can just take this, the destination max, and do promote parameter. And so what that should allow us is if I just come up to say, as it rises up around 120. So let's make both of them 0. This is fine, like it's going to hide inside the paper anyway, so it doesn't matter. So what I can do is I can just do alt click for both of these and then come to around say 190 and I'll make this minus 0.05 and this goes to, I don't remember what it was, so 0.1. Yeah, okay. So what will happen is, see, as it comes up, you get those, lines animating, which actually looks pretty nice. See, so you have like the cracks forming as it comes up. And then if we just come back to the VDB from Polygon and we make it say 0.06 and see, so you get like, nice little detail coming up. See, so this is like, now you need the fill interior, because if you don't turn that on, and also like why you need the exterior band voxels is because once it starts touching, you start getting like these hollow patches. So what you need to do is just increase it enough so it fills up. There you go. Let's try it at 6. Yeah, I think 6 is okay. Like don't increase it too much. I'd made it 40, which also makes it very slow. But see, like immediately it starts to slow down, but that's okay. Like it's not slowing down as much as it was. But this is nice. You can just animate the noise and get, nice little details on the whole thing. Okay, but this isn't what we want to do right now. But anyway, this is sort of taken care of, so which is good. Okay, so now what I want to do is I want to scatter points on top of this and make the bubbles. So the trick to the bubbles is that what we want is we want to animate the bubbles rising, and then when the bubble explodes, some of them form craters. Like not all of them form craters, but some of them will form craters. So which is why I didn't do a fluid simulation, because the problem was, if I do a fluid simulation, how do I get the bubbles to stick in specific places? So this way I can make it stick in specific places, which was, the whole trick behind it. So what I want to do first of all is at this point itself, I want to select the top faces. So I'll just do a group and we'll just call this top. And all I want to do is come to keep by normal, 1 in y-axis, 0 everywhere else, and just lower this so you just get like the top, like that. Okay. So we have the UVs in place and all of this, which is good. So now the advantage of this is if I come to this bulge and if I do a scatter, okay. So the problem with the scatter can be like if I just do a scatter right now and if I try to animate it, see, so the noise, like the points keep moving, which is bad, like which isn't what we want. So what you do is you change the generate from by density to in texture space, and then you'll see that, see, they stick. They're just moving based on, like because the sphere bulges, so the point moves. But otherwise, if I keep this pretty high, you'll notice that, see, they don't, like they stick in place, which is exactly what we wanted. And then I can take the group. Okay, so we have our points in place. Now what I want to do is I just want to lower the, the relax value, so they're kind of scattered. So this is fine, you can define how many points you want. And also I think I want to adjust the group. So let me just lower that. Yeah, I think this is okay. So we have like, points rising up like this. Okay, so the idea here is that we are going to animate one sphere expanding and then offset that animation based on the point number. Okay, so just randomize it essentially. So I'm going to take a sort here first of all, and I'm going to randomize the point numbers. The second thing is I want to take a simple add, okay, which will give me 1 point. Okay, so I'm going to take like 1 point. Okay, so which should be like down there. And what I want to do with this 1 point is I just want to animate the color. Okay, so I'm going to take a wrangle, or you can just take a, let's just take a wrangle. Okay, so I'm going to take a wrangle. We'll call it red. And I'm just going to do like at cd is equal to 0. And we'll do at cd.r is equal to, let's give it a value. Okay, so we'll just say, animate. Yeah, and all this does is it goes from like, we start at 0, we go to around 45 and go from 0 to 1. So what you should end up getting is just this, if you look at it, I know it's difficult to see, but let me just see if I can make the point size bigger. So I'll come to guides and point size. This is a little tricky. Hold on a second. Where's geometry? Yeah, there you go. Okay. So we can make the point size big. So if you look at this, see, so it just goes from 0 to 1. And then if I do so we're going to use a copy stamp. So copy stamp is technically deprecated, but for some things it's fairly simple. Like you don't want to do it for stuff where you want to compile it later for like, TD level work or things like that. But for simple things, it's fine. Okay. So we'll just take, if you take a copy stamp, and I will copy it onto all of these points. And what you'll get is basically this, so you'll just have like these things animating. But what I want to do is I want to animate the values of, I want to offset the animation on a per point basis. So I'm going to just take I'm going to take something called a time shift. So a time shift allows you to shift the animation. So just to show you what it can do is if I take by default it's like all the frames. If you subtract a number from it, that is how much the animation will offset. So if I say minus 100, so what's going to happen is now nothing happens and the animation starts after frame 100. Okay, so this is roughly what it does. So what we do is we do a stamp function. Okay, so you do a stamp ... we need to go to the copy. Okay, so we want to go to copy 3. So this is copy 3. And then you need to give it a name. So let's just call it shift. And then the default is 0. And then if you come to the copy, I'll turn off transform cumulative. Come to stamp inputs, type in shift. And I can just do at ptnum. And what will happen is you'll see like, these guys will start to, now this is a little, because there are too many points, it's happening fairly slowly. So you divide it by a number. So if we say divide it by 2, you'll get this. Okay. See, so this is roughly what is happening. Now the big question is, how do you turn these into bubbles? Okay, so how you turn these into bubbles is pretty simple. Take a wrangle after this. And I'll just do at pscale is equal to at cd.r. So whatever is the color here is how much it will scale up by. And I also want to give it normals. Okay, so what I'm going to do is I want to give it normals so that the spheres align with, actually no, just take a wrangle here. Or no, hold on. Yeah, just take a normal and keep it to points. So your geometry will have normals, okay, which is good. So technically this will also have normals. Yeah, this is normals, this is normals. Let's just see, come to attribute. Yeah, there you go. So turn on use template point attributes. Well, what this will help us is it will help us align the, the spheres to the basic cake shape. Okay. Okay, so this is good. So now what I want to do is if I just take a sphere for the bubbles, Every time I say bubbles, I just keep remembering Finding Nemo. Okay, but yeah, okay. So I'll just take I'll take a copy to points, and if I just plug these in, it should work. Okay, let's just make this really tiny. Yeah, and there you go. See, so you'll get them coming up like this. But along with this, I also want to randomize it. Okay, so let's just take a randomize. So we'll do an attribute randomize, and I want to randomize the p scale. We'll do a multiply. So you'll have like bubbles of different, sizes. So if you come up here, see, so you'll get this. And what we can also do is I want to take this sphere and squash it in the z axis. There you go. So it will be, they'll come up like this. Okay, so now comes the trick. Okay, so the trick is, what I want, as I said, is like the bubbles need to explode, right? Like they come up to a certain size and then they explode. So firstly, we want to do that. And the second thing is that some of them after exploding leave craters. Okay, like the small ones don't do anything, but the big ones leave craters, or, just randomly they leave craters. So what I can do is I can just come up here and I can do a group expression. So you do a group expression and you say, we want to select points, and I want to say delete, like let's call it delete. And we'll say at cd.r greater than 0.8. So what's going to happen is as they come up to like 0.8, they will delete, okay, or they will be selected. And then all I do is I take a blast and I delete those points. So you'll end up with having nothing, but what you'll get is, see, as they come up, they delete. And like that's roughly what we want. But now along with this, we need to really start pushing this down. That's okay. We have enough space. We have infinite space actually. So this is fine. Okay. And then if I turn this into VDB, so if we say VDB from polygons, and I'll get rid of that one. Yeah, so if I take another VDB combine, like rename this to density, and what is our size? 0.006. And let's just do a VDB combine here. And I can just come up here and I can say SDF union. See, and then we'll do a VDB smooth. So what you'll get is, see, as it comes up, you get bubbles forming. Let's do one thing. Let's just get this down to 0.01. Yeah. So it will play back a little more smoothly. Okay, so this is fine. But now what I want is, when some of them explode, they leave holes. Okay, so what we're going to do is we're going to do a small little trick. Is the points that we deleted, we take the ones that are left, like this is deleting, the selection. We delete an inverse of it, and then those points do a boolean or like a subtract. So this is doing a boolean union. We do a boolean subtract. Okay, so what we're going to do is we will duplicate this, do Control-C, Control-V, do delete non-selected. But what I also want to do is I want to take another, let's try a delete by range. I want to delete like a bunch of points from here. So let's just do delete by range. I want to delete points. Yeah. And say delete 2 of every 3. Yeah, so we don't want too many of them left. Yeah, I think this is okay. So we just have very few points left. And then I can just do Control-C, Control-V and plug in this. So what we'll get is, see, these will just appear. We can probably delete more. Let's go to 5 and we'll do 4 of every 5. Yeah, okay. And again, like this will come in here, do Control-C, Control-V. And we'll do a VDB combine again. We plug this in, and this will be an SDF difference. See, so you'll get holes like these. So what will happen is that, you'll get bubbles, and then when some of the bubbles explode, they leave holes. And that's basically how you do that. Okay, so if we add noise after this, once it comes up, you'll start getting holes and the cracks. And see, the holes stay in place because they sort of move along with the geometry. So yeah, I can't do a smooth playback because it's starting to get heavy and it will slow down. But there you go, like this is basically what you do. Like if I come in here to the VDB smooth, or let's try to do like at the combine itself. See, so as they explode, some of them start to leave holes. So yeah, for static things like these, like not for like flowing liquid or whatever, but for static things like these, this is a pretty decent way to do bubbles. So yeah, so this is basically it. Okay, so in the next video, we will take a look at how to form like an actual crack. Like if you really wanted to break up, we can do an actual crack on top of it. So it's not necessary because you're also generating cracks based on the noise map itself. But if you want a specific crack to form somewhere, I'll just show you how to do that in the next video.